Well, Math 098, we're moving on to section 3 where we're just simplifying radicals. And the main thing, and I sort of touched base on it in section 2, is that the index needs to be the same in order to combine them together. So that's a big deal. It has to have the same index when you're multiplying. It's a little bit trickier if we're trying to add or subtract. So anyway, this is just the same thing as the square root of 35. And there's nothing else you can do right there. The next one, square root of 13z. Now this next one, there's two ways you can do this. And if you're using the calculator, it makes the most sense just to rewrite this as the fourth root, because the index is the same here, of 625. And then when you do the fourth root of 625, you actually get an exact answer of 5. Now the different way, if you don't have a calculator, you might want to factor tree down. Well, clearly if 125 times 5 equals 625, then you can break down 625 as 125 and 5. And then break that down as 25 and 5. And break 25 down as 5 and 5. And when you identify that you have a group of 4 5s, that must be the fourth root of 625. So as I move forward to the next problem, there's really not much to do. The index is the same, so just combine them. 5 times 3 is 15. As a math person, my habit's to write the alphabetical order, so x squared before writing y. But that's it on that one. And then this last one, if you're multiplying fractions, just a reminder, you multiply numerator with numerator, so it's just 5t over 2m. And there's nothing to simplify there. However, with a radical, we want to rationalize the denominator. So let me give you a heads up on that. Let me just find some empty space here. So that's the same thing as the square root of 5t over the square root of 2m. And what you're going to see me do is I'm going to rationalize the denominator because this is an irrational number. So what we do is we multiply top and bottom by the denominator. And what we end up with in the numerator is 5 times 2 is 10, still under the square root, mt. Now in the denominator, I'm going to show you step by step, but there's a shortcut. Is 2 times 2 is 4, and m times m is m squared. Well, the square root of 4 we know is 2, and the square root of m squared will cancel each other out, so it's left with m. So if we're rationalizing that denominator, notice the shortcut is multiplying top and bottom by the square root of the denominator will give you the square root goes away, and we're left with the answer that we want. So that's kind of a precursor to what we're doing next. Now before I do this, what I need you to do is to recognize that we cannot leave a radical in the denominator, but this one's pretty easy because there is, as we square root each piece, they're going to be perfect. The square root of 36 is 6, the square root of 49 is 7. Okay, that's what they mean by the quotient rule. Just do each piece individually. So I'm not going to show that step again. The square root of z over the square root of 16, which is 4. This one, the cube root. I think it's beneficial to memorize a few cube roots, but if not, you can use a calculator. So the cube root of 125 is 5, and the cube root of 8 is 2. You can check with the calculator. Now this one, not as easy, because the fourth root of 5 is not a perfect number. So just leave it as the fourth root of 5. And in the denominator, the fourth root of 81 is 3. Now remember, we can divide the index. 8 divided by 4, so this becomes x squared. And that's all of exercise 2. Now moving on to exercise 3, I have a particular way that I like to simplify. By the way, we're doing simplest radical form. And it might be slightly different than how you've learned it in the past. So you don't have to do the problem my way, but my way does work. And what I do is I factor tree, so 49 and 2, break down 49 to 7 and 7. Until you get all prime numbers at the bottom, you look for pairs of the same number, and the pairs go in front, and what was not a pair stays under the denominator. And this works. Before showing you the calculator, I do want to point out that what I'm really doing is I'm really rewriting the square root of 98 as the square root of 49 times the square root of 2. Well, what is the square root of 49? 7. So 7 square root 2. Now, when I say check with the calculator, what I'm talking about is typing into your calculator the square root of 98 and then typing in 7 square root 2, and I get the same decimal. So since I have the same decimal, I know I did the problem correctly, 9.899. So it must be the correct answer. Yeah, so let's move on to the next one. As I break this down, prime numbers 5 and 7 are prime, but there's no pairs. So if there's no pairs, then what that means is the original problem was exactly right, because we have nothing to bring in front. And if you want, you can go ahead and rewrite it this way of the square root of 5 times 7, which is the square root of 35. Because only the pairs go in front, and we write the pair once. And then anything that didn't have a pair stayed under the radical, and you multiply them. As we move on to the next one, notice now we have 2 and 27, but now it's the cube root. So I do 3 and 9, 3 and 3. Now I need a group of 3 numbers because of the cube root. So this answer is 3 cube root of 2. So feel free to pause the video. I want to show you with the calculator why that's the correct answer. So under the math tool, looking for the cube root of 54 gives me a decimal, and I'm telling you that that equals 3 times the cube root of 2. As I type that in, you see I get the same exact decimal, 3.780 approximately. So that must be right. 3 cube root of 2 must be right. And then there's another one. I'm not very good at dividing by 3, so I need a calculator to help me out. So I'm going to do that. 243 divided by 3, divided by 3. Okay, I think I can do it now. 81, 3 and 9, 3 and 3, nope, 3 and 27, 3 and 9, and then 3 and 3. So I'm looking for a group of 4 3s. All right, so there's 4 3s, and then there's 1 left over. So I write the group of 4 once, and then the 4th root of 3. This 3 that didn't have anything to go in front. And you can double check that that's correct with the calculator. Kind of just throwing out a few more things in here for you is getting you to really understand. So if you were to break down the square root of 6 times 6 is 36. So there's a pair. By the way, once you get better practice with this, you don't have to look for prime numbers. You just have to look for a pair. If anybody's going to argue with me, go ahead and get all prime numbers. And you have a pair of 2s, and you have a pair of 3s. Well, remember, you multiplied those numbers together, so what's 2 times 3? 6. But again, I like to write it all out. 3, 4, 5, 6, 7. Because we're looking for pairs, there's 1, 2, 3 pairs of z's. So that's z cubed, and then there's 1 z left over, which is staying under the radical. This is your final answer. 6z cubed square root of z. There's other ways of understanding it, for the record, because I've seen students that will actually work through, because remember this index is 2, and they'll write z to the 7 halves. And then I have an issue with this because I've seen students do this wrong. But anyway, 7 halves is 3.5. So what they'll do is they'll put the 3 in front And then they'll have to think about, well, 0.5 means it's the 1/2 power, which the 1/2 power means the square root. So that is an option for anybody that would prefer to do a problem that way. I do have issues with it, but just want to point out that there are multiple ways of doing this. So if I were to break down 32, we got 2 and 16, 2 and 8, 2 and 4, and 4 does break down, but there's no other groups of 3. There's one group of 3. And then we have 4 P's, but again, I just want one group of 3, and then I have 7 Q's. 2 groups of 3 Q's. So what's my answer? I have 2, 1 P, I have 2 groups of Q's, and then under the radical is the cube root of 2 times 2, because that was not a group of 3, so that's 4. I had 1 P left over and 1 Q left over, and this is your answer. I get it that this might be difficult, so feel free to write down any questions you might have and bring it to my attention. So again, 16, 2 and 8, 2 and 4, 2 and 2. So we have a group of 4 2's. Good, we can write that in front. We have 15 x's. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're looking for groups of 4. There's 1, 2, 3 groups of 4. And then we have my leftovers, because we don't have enough for a 4th group of 4. So we put all 3 of those into the radical. There you go. Again, feel free to pause the video at any point, rewrite them, and try to go from there. So as I move on to exercise 5, I want you to recognize that you can divide as long as the index are the same. So the best way to do this problem would be to figure out what 80 divided by 5 is. So this is the same thing as the square root of 80 divided by 5. So just make sure that they have the same index and they're both radicals. So just to double check, I'm pretty confident that 80 divided by 5 is 16. Yep. So we're looking at the square root of 16, which we all know is exactly 4. So these problems aren't necessarily like super easy. As I look at the next one, you can't move this 3. You can't take 98 divided by 3 because the 3 does not have a radical. But you can do 98 divided by 2 because they both have a radical with the same index. So if you do that, 98 divided by 2 is 49, and it stays under that radical, and that 3 is still in the denominator. I hope that makes a lot of sense. Because then as you reduce that, the square root of 49 is 7 root z all over 3 is what I'm looking for. So as I do the next one, notice my index is the same for both. So I can reduce this. 40 divided by 5 is 8. We still have that x to the 5th. And as I subtract y to the 7th minus y to the 1st, because that's our rule for exponents, it's y to the 6th. Now as I work through this, I know the cube root of 8 is 2. Let me just show that step. So that can move in front. I have one group of 3 x's. I have 2 groups of 3 y's. But I have a few x's left over. And I might need to show that work. Let me show that over here. Is 1, 2, 3, 4, 5 x's. I had one group of 3, so it was x to the 1st brought in front. I had 2 x's left over. But y to the 6, I had 2 groups of 3 y's with none left over, so nothing under the radical. So what's the best answer? It would be 10xy squared cube root of x squared. And I'll have to pick up on this last example in the second video.